So in this video we'll be learning how to integrate trigonometric functions, and let's start with this small example. We have integral of cosine to the cube power x dx, and the first step or thing we need to do is divide it in two parts. So let's rewrite it as integral of cosine x squared times cosine x dx. And another basic rule that you always need to remember is sine squared x plus cosine squared x is equal to 1. And in order to solve this, we normally need to use U-substitution method. So we need to replace cosine x squared by 1 minus sine squared. So it's going to become, if I do the thing here, so it's going to be cosine x squared is equal to 1 minus sine x squared, and here we can rewrite it as 1 minus sine x squared. You will see why I'm doing this. And the other thing is cosine x dx. And now we can choose something as u such that the derivative of u cancels out cosine x. So if we choose sine as u, du is going to be cosine dx, and if we replace dx with du over cosine x, this is going to cancel out with this. So now let's rewrite it in u terms. So it's going to be 1 minus u squared and close brackets cosine x, and dx is du over cosine, so cosine, and this cancels out with this. So we can just simplify this and write du, and now just integrate this normally. It's going to be u minus u3 to the power third over 3 plus c, and you always need to replace what was u from the beginning. So it's going to be sine x minus sine cube x over 3 plus c. Let's move on to another example here. So again, the first step is to break it in two parts. So I'm going to do cosine to the power of 4x and then cosine x dx. And as we know from before also, cosine x squared is equal to 1 minus sine squared x, and we can write cosine to the power of 4x in terms of cosine 2x squared cosine x dx. And now we can replace cosine squared x with this part here. So it's going to be integral of 1 minus sine x squared and squared again from the brackets cosine x dx. And again, now we need to decide what to take u as. We need to take u as sine such that du is going to be cosine x dx, and this will cancel out with this part. So we can just replace this with du now. So let's do that. Integral of 1 minus u squared again, and this part is du now, so just write du, and let's simplify this now. So this is basically a minus b squared, so it's gonna be a squared, which is gonna be 1 minus 2ab, so 2a is 1 and b is u squared, plus b squared, which is gonna be u to the power of 4 now, du. And now we just integrate this. So we get u minus 2u3 over 3 plus u5 over 5 plus c, and now replace u as sine x. So it's going to be sine x minus 2 sine x squared. Oh, it's cubed, never mind. over 3 plus sine to the power of 5x over 5 plus c. This is the final answer. So let's move on to the next example, which is integral of cosine to the power of 5x times sine x dx. So what do you think we should take u as in this case? And this integral is already in two parts if you think about it. So if we take cosine as u, let me write it again. Du is going to be negative sine x dx, and this will cancel out with this part over here, so that just works out for us then. So let's replace it with u now. So it's going to be integral of u to the power of 5 times du, and don't forget there is a minus sign, so I'm just going to take it out here, and we just integrate this normally. So it's going to be u6 over 6 plus c, and then minus, now replace u with cosine x, so I'm going to write cosine x to the power of 6 over 6 plus c. So this is a simple example. So what do you think we should take u in this example to be? We have sine to the power of 5, which is an odd number, and cosine to the power of 2, which is an even number. So in this case, we always need to take u to be the even number, such that, because if we rewrite sine as sine to the power of 4 times an extra sine, we can use u as cosine x, and the derivative of cosine x will cancel out sine. So let me show you that. So let's first of all divide sine to the power of 4 and sine x and cosine squared x dx. We can rewrite sine to the power of 4 in terms of sine to the power of 2 and 2 outside, sine x cosine squared x dx, and now we can replace this with 1 minus cosine squared x, so that will be equal to 1 minus cosine squared x squared sine x. I'm just going to move the sign to next to dx, so it's more simpler to understand. So cosine x sine x dx, and now let's take u to be cosine x. Du is going to be equal to minus sine x dx, and now we can replace cosine with u, and we can replace this part with du. So integral of 1 minus u squared, again squared, and this is just u squared, and this part is going to be du, and don't forget that we have a minus sign over here, so I'm just going to take it out here. And now let's simplify this more. So this is going to be minus integral of a squared is going to be 1 minus 2ab plus b squared. So u to the power of 2 to the power of 2 is a u4, and this is all multiplied by u squared again. So I'm just going to rewrite it now again. So minus integral of 1 times u squared is u squared, minus 2u squared times u squared is going to be minus 2u to the power of 4, and u to the power of 4 times u to the power of 2 is going to be u to the power of 6 du, and now we can just take the minus sign into our integral, so it's going to be minus u squared plus 2u to the power of 4, and this is going to be minus, and now we just need to integrate this. So I'm going to write it up here now, equal to minus u to the power of 3 over 3 plus u to the power of 5 over 5 minus u to the power of 7 over 7 plus c. Now the final step which is left is just substituting cosine x with u, so that's going to give you minus cosine x cube over 3 plus 2u cosine x to the power of 5x over 5 minus cosine 7x over 7 plus c. So now what if both of the powers are odd? So which one is it easier to take u as to be? So in this case, the easiest step is to split cosine cube in two parts, and I'll show you why. So let's just do that for now. It's going to be sine to the power of x cosine squared x times cosine and extra cosine dx. And now we can replace this with 1 minus sine squared and this is going to be left as cosine dx. Now if we decided to split sine to the power of 5 in sine to the power of 4 and sine, we would have to split this into sine to power this squared, and this would have to convert into 1 minus cosine squared to the power of squared. So it's way more complicated to do that rather than doing this. So it's always better, if both of the powers are odd, it's better to isolate the smaller power and using the other element as u. So let's take sine now as u. So u is gonna be sine x, du is cosine x dx, and we can just replace this with du now, and it's gonna be u to the power of 5 into 1 minus u squared, and this part is du, and just simplify this now. It's gonna be u to the power of 5 minus u to the power of 7 du. Integrate this now, so it's gonna be u to the power of 6 over 6 minus u to the power of 8 over 8 plus c, and now replace u as sine x. 6 minus u (8x over 8 plus c). Now I will be making a short video on how to recheck your answer on the calculator of any indefinite integral. So I'll just give you a short demo how to do that. So we have the final answer here, and if you want to recheck from the question, what we can do is we can put any two values in your calculator, which is going to be, let's say, 0 and 1, and we can just integrate the question and get the final answer. So let's say 0.3, and in the final answer what you have to do is substitute 1 in the x minus you replace the entire thing, replace with x with 0, and if you get the same answer, this means that this answer is right. So it will be more simpler if I made a video on that, and I'll make that soon now. So thanks for watching.